Hello everyone, welcome to the 10th tutorial session of the SWAYAM course Problem Solving Through Programming in C. So this is a course that has been floated by Professor Anupam Basu from Department of CSE IIT Kharagpur. I'm Siddhant. I'm one of the 3 TAs who are in charge of taking these tutorial sessions where we will discuss the week's lectures and a few questions which will help you out with assignments as well as the final exam. So in this week, that is week 11, the lectures covered a bit more about recursion and about interpolation techniques such as Lagrange interpolation and we also looked at RK4 methods to solve differential equations, right? Now so let us see a few questions about that. So first I have a few questions on interpolation techniques, so wherein we discuss especially the Lagrange interpolation technique. Now the question states that a Lagrange polynomial passes through these 3 data points as given to us, which is x and fx, and the polynomial is determined by this equation, which is fx is equal to L naught of x into some value plus L1 of x into some value plus L2 of x into some value. So the question asks what is the value of f of x at x equal to 12. So now if you remember how to calculate the Lagrange polynomial, this L naught x, L1 x and L2 x has to be calculated. So let us do that. So I'll first calculate L naught of x. So I can write that as, so for L naught of x I'll consider reference point as 10. So 12 minus 15 by 10 minus 15 into 12 minus 20 by 10 minus 20, right? Similarly for L1 of x I'll do 12 minus 10 by 15 minus 10 into 12 minus 20 by 15 minus 20, right? Similarly for L2 of x, here L2, so x is equal to 12 in all these cases because that is where we need to find the value of the polynomial, Lagrange polynomial. So for this it will be 12 minus 10 by 20 minus 10 and 12 minus 15 by 20 minus 15, right? Now let us calculate each of them. So the first one is minus 3 by minus 5 into minus 8 by minus 10, right? So 0.48. Then this now L1 of x is 2 by 5 plus minus 8, sorry not plus, multiplied by minus 8 by minus 5. So that gives us 0.64, and the third one is 2. Alright, and the third one is 12 minus 10, that is 2 by 10 into minus 3 by 5, right? So it's minus 0.12. So now if we put if we substitute L0, L1 and L2 into this f of x, what do we get? Let us calculate that. 0.48 into 19.45 plus 0.64 into 10.63 plus 7.82 multiplied by minus 0.12, which is roughly 15.20. So f of x you can calculate it by 0.48 into 19.45 plus 10.63 into 0.64 minus 0.12 into 7.82. That brings the value to 15.20. So here the answer is option C. Is that clear? How to do a Lagrange interpolation and calculate the value of interpolate. So we had 3 points here at x equal to 10, x equal to 15 and x equal to 20, and using this Lagrange polynomial we calculated the value of the function at x equal to 12, and so this is how you would do it. So this is f of x at x equal to 12. So the value came out to be 15.20. Now we will take a similar approach with the second one. So here the question just asks for calculating the value of L1, not for the entire value of fx. So we will do just that. So how do you write L1 of x? So L1 of x, meaning if we have 3 data points, so L1 of x, we go to the second data point, we write the equation in reference to that. So x minus 10 by 15 minus 10, right, into x minus 20 by 15 minus 20. Okay, now if I put x equal to 18, then L1 of x, what should it be? So it will be 18 minus 10 by 15 minus 10 into 18 minus 20 by 15 minus 20. And what is that value? It's 8 by 5 plus multiplied by minus 2 by minus 5, which is 0.64. So we got L1 of x to be 0.64 at x equal to 18. So that is what the question is asking. So this will be 0.64. Is that clear? How do we calculate the L1, L0 of x, L1 of x, and L2 of x? And how do we calculate the value of a function, rather interpolate the value of a function at a value in between this, in between the data points that we have? I hope it's clear to everyone. So we'll move on to the next question. If you have any doubts, you can probably unmute and ask, or you can even write in the chat. Okay, so let's move on to the next question. So next we look at integration, how to do integration, especially using this trapezoidal rule. So if you remember, so if I do this, we have some plot which is x versus fx, and we have some line which goes like this, say, which is non-linear, and you want to calculate the area under the curve. That is basically what the integration basically means, right? You need to calculate this fx of dx in a certain zone a to b. So within this a to b, I want to calculate the area under the curve. So what I do is I take this to be a trapezium. I can take multiple trapeziums actually. So if I take as a one segment trapezium, so that means from a to b we have this trapezium which has the height of f of a and f of b, height of the sides, and this the sides to be f of a and f of b, and the height is b minus a, and we have to calculate the area under the trapezium, which would be half into, so the area would be half into b minus a, which is the height of the trapezium, into the sum of the sides of the trapezium, which would be this. So this is if it is a one segment trapezium, right? One segment trapezoidal rule. So this is basically what trapezoidal rule means. This is a method to calculate the area under the curve or do an integration. Now you can also divide this entire part into smaller trapeziums and you can calculate it. So the smaller the width you take for the trapezoidal rule, that is the more number of segments you take, usually you will get a better output, I mean the more accurate result compared to the actual integration value. So here in the question, however, it asks to take only a single segment trapezoidal rule, so we will do that. Now our limits are 0 and 3.2. So first let me write this, that f of x is the equation, or rather the function that needs to be integrated is x into e to the power x. Now what are the values of x into e to the power x at x equal to 0? So f of 0 is 0, as you can see that, and f of 3.2 we can calculate that. So it's 3.2 into e to the power 3.2, so that gives you around 78.5. Now according to this, we will put the single segment trapezoidal rule, so it's half into 3.2 minus 0 into the sum of the sides, which is this. Now if you calculate this, you will get 3.2 by 2 into 78.5, which is 125.6. So this is the area under the curve for x into e to the power x from the with the limits 0 to 3.2. However, you can, if you actually do this computation or do this integration analytically, you will observe that it's actually different than this. That is because we have taken only a single segment, which gives you the maximum error. So the more number of segments you take in the trapezoidal rule, the closer to the analytical value you will get. The numerical integration value will become closer to the analytical integration value. So here, using a single segment trapezoidal rule, we obtained a value of 125.6. So this is the answer. Now we can have a look. At the next question, which is again a single segment trapezoidal rule using another function, which is x square into e to the power 2x. Now as usual, we will calculate the values at the limits first. So the lower limit is 0, so we calculate f of 0, which you can see again is 0, and we calculate f of 3, which is the upper limit. Now we calculate that, so it's 9 into e to the power 6, right, and you get 3630.86. Now to calculate the area under the curve using a single segment trapezoidal rule, so we take half into 3 minus 0, that is limits, into the sum of 0 and 3630.86. Now how much is this? So it's 3630.86 into 1.5, so that gives you 5446.29. so that is the area under the curve, which roughly is, I would say, 5446.3, which is option A. I hope there is no doubt till now regarding the trapezoidal rule.
Explain again, sir.
Okay, so the trapezoidal rule, basically you have to calculate, it calculates the area under the curve. So the area under the curve you can calculate. So you have this integration. Basically what this integration means is that you have a function which is x square into 2 to the power into e to the power 2x, and you want to calculate the area under the curve from 0 to 3. So say this is your function, which is fx, and your this a is 0, b is 3, and you are calculating the area under the curve. That is basically what integration means. Now using a single segment trapezoidal rule, what we do is we consider this entire part under the curve as one trapezium. Now if you consider it as a trapezium, the length of this side is f of a, the length of this side is f of b, and the height of the trapezium is b minus a. And the area of the trapezium, the formula for the area of the trapezium is half into the height into the sum of the sides. So that is what exactly we do. So we have this function which is x into e to the power 2x. We calculate the value at the limits, which is f of 0, the value is 0, and at f of 3 we calculate the value, which is 3630.86. Now the area of the trapezium would be half into the height, which is 3 minus 0, into the sum of the sides, which is f of 0 and f of 3. So the sum of the sides, so if you calculate this, we get 5446.29. so this is the integration, or this is the value of the integration of x square into e to the power 2x from 0 to 3 using one segment trapezoidal rule. Is that clearer now?
Okay, sir.
Yeah. Okay. Then we will move on to the next question, which is again using trapezoidal.
How did you write 1 by 2 into 3 minus 0?
Yeah, this is basically the area of a trapezium. So if you have some trapezium, so this is a trapezium, and you want to calculate the.
Why you consider only x values as 0 and 3?
Yeah, because that is the limit. That is the limit that you have to take. That is the limit you have been given to calculate the definite integral. So this is a definite integral where you have to calculate within the limits of 0 and 3. That is what the question states, that you have to calculate the integration of this function from 0 to 3. So that is why I have taken this 3 minus 0. So basically what this is this point is 3, this point this point is 0, this point is 3, this is f of 0, this is f of 3. Now area of this trapezium is this into f of 0 plus f of 3. So that is basically what I have done here, because this is the height and these are the two sides. So this is the height of the trapezium. This is one side and this is the other side. So the sum of the sides. So basically this is the height, half into the height into the sum of sides. So that is how you calculate the area of a trapezium. So that is what I have done here, because we have to calculate the area of this function from the limits 0 and 3, and you need to use only a single segment, that has been told in the question itself. So I take the limits to be 0 and 3, and that gives me the height as 3 minus 0 and the sides as f of 0 and f of 3, the sum of which I have taken and multiplied. Is that clearer now?
Yes, sir. Thank you, sir.
Yeah. Okay. Alright, so let's go to the next question. So here we do the trapezoidal rule, but as you can see there are multiple points here. So we will be taking so here we have 5 points, so we will consider 4 trapezoids in between them. So the first trapezoid will be between 1.4 to 1.6. So let us calculate the value, and the value has also been given to us. So I am going to directly write the area under the curve. So the area would be half into 1.6 minus 1.4 into, so that is the height, 1.6 minus 1.4 into the sum of the sides, which is 4.3215
1.6
plus, sorry, it's 1.
Sir, we should need to consider either the upper limit and lower limit, no sir?
No, actually here you have multiple points. There we had only a single trapezoid, so it was called a single segment trapezoid. So basically what we did is, if this is the function, we had only a single trapezoid in between them, so we considered only a single trapezoid. But in the case now that we are seeing here, if this is the function, so we will consider this as the first trapezoid, this is trapezoid 1, this as trapezoid 2, this as trapezoid 3, and so on. So we have 4 different trapezoids here between the first trapezoid is between 1.4 and 1.6, the second trapezoid between 1.6 1.8, and so on. So we have 4 different trapezoids here. So we have to calculate the area under the curve of each of the trapezoids separately.
Sir, then what is the value of y?
Y is basically this, the f of x that we said in the previous question, that is the value of y. So from the value of y will actually give us the side, the length of the side of the trapezium, which we need to add up. So it's the area of the trapezium is half into the height into the sum of sides, right? So the sides, the value will come from y, which is basically the f of x that we were talking about earlier. So this will be 4.74 into this. So this is the area of the first trapezium. Then you have the area of the second trapezium, which is from 1.6 to 1.8. So it's 1.8 minus 1.6 into this sum of these two values. So 4.7428 plus 5.5205. Then we have the third trapezium, which is half into 2 minus 1.8 into 6.0525 plus 5.5205, the sum of these two, which are the sides. Then the fourth trapezium, which is 2.2 minus 2 into 6.0525 plus 6.8762. So if you calculate all of this, you will get the answer. You will get the answer to be roughly. I think we have to calculate this and check. I think you will get a value of around 4.3829. You can calculate this and check. So the answer that you will be getting is 4.3829. You take 4 different trapezoids.
In previous question you had added the limit values like 3 plus 0. No sir, now you are adding the size of the trapezium.
I had done 3 minus 0, not 3 plus 0. So the limits, because that is the height of the trapezium, so you have to do b minus a, right? So that is what I have done in both cases. So that I have done there as well. So this is the height and this is the sum of the sides. So that is what I am doing there itself. So the trapezium, the first trapezium, the limits are 1.4 and 1.6. So I am doing 1.6 minus 1.4, which is the height of the trapezium, and the sides, which are 4.3215 and 4.7428. So these are the sides, sum of the sides. Now half into the height into the sum of the sides, and I do that for all the trapeziums, which is the first trapezium is from 1.4 to 1.6, the second trapezium from 1.6 to 1.8, the third from 1.8 to 2.0, and fourth from 2.0 to 2.2. So I take all the trapeziums separately, calculate their area under the curve that has been asked in the question, so area under the curve, and accordingly I calculate that and I get a value of 4.3829, which is option A. Is that clearer now?
Yes sir.
Okay. Alright, if that is clear, then we shall move to the next question, which is root finding. So root finding basically means find out where the value of the function reaches 0. So we have this function, which is if I write the function, it's x to the power 4 minus x minus 10. Now we have to find out numerically where the f of x will become 0, at what x value, and we have been told that the limits, we have to do it using the bisection method that we discussed in the previous lectures, in the previous week's lectures and the previous tutorial class as well. I solved a few questions from bisection method, so this is kind of a revision of the previous tutorial class. So in bisection method we need two limits where we need to start from, two initial conditions. So here the initial conditions are already provided, which is a is equal to 1.5 and b as 2. So first what we do is we calculate f of a and f of b, that is the value at the limits. So let us do that. It's 1.5 to the power 4 minus 1.5 minus 10, so it's roughly minus 6.44375, and we calculate it at 2 as well. So 2 to the power 4 minus 2 minus 10, so it's 4. So as you can see, both the f of a and f of b have opposite signs, which is necessary for the limits, for the initial conditions, or for any of the conditions for the bisection method. Now what do? Is we calculate the value. So this f of a, which was 1.5, and f of b, which was
f of b 3, 4.
Yeah. So we are doing 2 to the power.
Sir, we need to substitute b value in place of x, no sir?
Yes, yes.
2 power 4.
2 to the power 4 is 16 and minus 2 minus 10, so minus 12. So 16
Okay,
minus 12 is 4. Yeah. So okay, now we calculate. So now if both are on opposite sides, that is opposite signs, so we calculate the value at 1.5 plus 2 by 2. So basically the midpoint of 1.5 and 2, which is 1.75. So we calculate the value at 1.75, and this is the first iteration. This is the first iteration of the bisection method.
How did you get 1.75?
Actually, for bisection method, you can go back and look at the previous tutorial session. So what we do is, if we have a function like this, and this is say x and this is fx, and we have, okay, here it's the opposite, but okay, let me, okay, so here we have a function like this, something like this. So we have at value of 2, this is a positive value. At 1.5 we have a negative value, and there is a root somewhere in between. So what we do in bisection method is, we go to the midpoint of 1.5 and 2, which is say 1.75, where we might where the value might still be positive or negative. We have to calculate that. So yeah, it's still negative, so it's 2.37. so it is not actually here, but yeah, so 1.7, this is 1.75, and the value is still negative. Next, what we do is, we consider 1.75 and 2 as the limits, and we again go to the midpoint of that. So if you go to the midpoint of that, we have to calculate the value of 1.75 plus 2 by 2, which is how much? 1.875. So we have to calculate the functional value at 1.875. So what is that? 4 minus 1.875 minus 10. So that gives us a positive value, which is 0.4846. Now 0.4846, so we are somewhere here. This value is 1.875. Now we are now, instead of taking 2 as the upper limit, we will take 1.875 as the upper limit and 1.75 as the lower limit. So using that, we will calculate, we will again do a bisection there. So if you do a bisection, that is 1.75 plus 1.875 by 2. So you have to calculate the value at 1.75 plus 1.875 by 2, which is basically 1.8125. So f of an 8125, 1.8125. So you'll calculate this value and you will get something. So you have to do this for 5 iterations, that has been told in the question. So if you do it till 5 iterations, you will see that you will reach a value which is around 1.86. So if you continue the calculation beyond this, I have done it till the 2nd iteration. If you continue like this for 5 iterations, you will get a value which is very close to 1.86. So I'll do it for the 3rd iteration only, then the rest I'll leave it to you.
Sir, how do you get 0.4846?
Yeah, you put the, so it is basically f of 1.875, which is you put the value of 1.875 in f of x, which is x to the power 4 minus x minus 10, and you get that. This you get as minus 0.02. Okay.
Sir, why you take the bisection between 1.75 and 2?
Yes, because yeah, by bisection method, what you do is, you try to get to the root, right? To the root means where the function value goes to 0. So you need to get closer and closer to the root, and how you do it is, first I had this limits which is 1.5 and 2. I calculated the midpoint which is 1.75, and I saw that the midpoint also, this which is 1.75, it is also a negative value. So if you want to get closer to the root, you take now 1.75 and 2 and again do a midpoint. So I did that, I got 1.875. Now I saw that the value at 1.875 is positive, that means it is after the root. So the root will be lesser than 1.875, but I know that it will be greater than 1.75. So I take 1.75 and 1.875 as the limits, and I again do a midpoint, calculate the midpoint, and the midpoint I get it as 1.8125. Now I see the value at 1.8125. I see that the value is negative, and so the root should come after 1.8125 and before 1.875. So I take those two as the limits and I continue doing the midpoint, so until I do 5 iterations.
Sir, for bisection we can take any values, it's our wish.
Yes, it just needs to have opposite signs. So if you can take any starting values, like here it is provided 1.5 and 2, but you can take any starting values provided that one value is before the root, the other value is after the root. That means one value you will get a functional, the f of x at one of the values, one of the conditions should be negative and the other condition should be positive. That means the values, the initial values that you take should be on opposite sides of the root. That is a necessary condition for bisection method. So
how you can justify that the answer is 1.8?
yeah, continue doing that after up till the 5th iteration and you will get the answer. I have solved it, that's why I can say that it's 1.86, but you can continue doing it after.
For next iteration we can take any bisectional values like
Yes.
1.75 plus 1.2.
No, not 1.75, because you see now 1 minus 1.02, the value is actually closer to 0 than this, right? So you had 1.75, but now you have 1.8125, which is closer to the root than 1.75. So you have to take 1.8125 and the closest upper value, which is 1.875 for the 4th iteration. So these two values you have to take for the 4th iteration. You find the midpoint.
I couldn't understand how you're taking to bisect.
I think you should go back and look at the week 10 lectures, yeah, where the bisection method has been covered, and I have also explained it in the previous tutorial. So I think you can go back and look at that.
Okay, sir.
Okay, so let's look at the next question. So it's again a root finding, and here you have the function which is f of x is 5x minus 2 cos x minus 1, and you can use any method that is known to you, that has been told already. So you can use the bisection method or you can use the Newton-Raphson method. I think that has also been covered in week 10. So here I'll be showing you the Newton-Raphson method. So we need a single initial condition for Newton-Raphson method. Let's say I take I take x equal to 0, right? Now what is f of x as at x equal to 0? It would be 2 cos 0 and minus 2, so minus 3 basically, right? And yeah, we need to find the real root of the equation. All right, so the way to do this is, so x0 was 0. Now what we do is x1 is x0 minus f of x0 by f dash x0. This is basically the Newton-Raphson formula, So if you calculate, so let me calculate f dash x. So f dash x is minus 2 5 minus 2, the differentiation of cos x is minus sin x, so you will have this, right? So 5 plus 2 sin x, that is the differentiation. The first the if you differentiate f of x once, you will get 5 plus 2 sin x. Okay, now that is what I'll put here. So x1, so let us calculate x1. So x1 is 0 minus, sorry, it's x1 is 0 minus, you have f of x0, which is 0, which is minus 3, that is this, divided by f of, so I calculate f dash of x0, which is what you put x equal to 0 here. So what do you get? You get 5, right? So this, so what is 3 by 5? 0.6, and this is added up, so plus 0.6. So x1 is plus 0.6. Now we calculate x2. So how do we calculate x2? Similar procedure, x1 minus f of x1 by f dash x1, and if you calculate this, let's see what you should get. 0.6 minus f of x1. So let me write this down. 0.6 minus f of x1, what is
how f of x equal to minus 3?
Yeah, if you put if you put x equal to 0, so my x naught is actually 0. I have taken this initial condition, which is x naught is equal to 0, and if I put x naught, if I put x equal to 0 in f of x, I get minus 3, because cos of 0 is 1, so minus 2 and minus 1, so total of minus 3. So that is what I put here. And similarly f dash x, if I calculate at 0, sin of 0 is 0, so you get only 5, so minus 3 by 5, right? Now if I calculate f of x1, so I put 0.6 into this f of x equation, so 5 into 0.6 minus 2 into cos 0.6 minus 1, right? So it's roughly 0.349 divided by f dash of x1, so f dash of 0.6, so f dash of 0.6 means 5 plus 2 into sine 0.6, that is 6.129. so I calculate this, I get 0.6 minus 0.39349 divided by 6.129, so it is 0.543, right? Now this is the second iteration, so you have to, so till when do you have to continue this? So it has been asked up till second. Yes,
Sir, how 0.349 by 6.129?
Just put the values there. So x1, just put x1 is 0.6, just put that in f of x.
Sir, 5 into 0.6, in place of x, we are substituting the value of 0.6, sir.
Yeah, that's what we are doing. So that is, so here I have written x1 is 0.6, right? So that's what we have put, 0.6 in place of x, and we calculate f of x and f dash x. So that is how we get 0.543. So we need to continue this until, so it has been asked up till 2 decimal accuracy. That means your xn plus 1 and xn should be, once you get less than 0.01, that means that is where you stop, because it has been asked 2 decimal accuracy. So say I calculate some x5 and I calculate and I compare it to the previous one. So here if I do the comparison, x1 minus x0, the value was 0.6, right? Similarly x2 minus x1, if I do, so x2 minus x1 is 0.543 minus 0.6, which is minus 0.057. but still you can see that it is more than 0.01. So the absolute value is more than 0.01, right? So absolute value of this, okay, so absolute value is still more than 0.01. So we need to continue until this difference between consecutive xn plus 1 and xn becomes less than 0.01, and whatever, if this happens, then your xn is the xn is the root. So here however, you don't need to calculate a lot of steps for that, because a range is given and you will be able to figure out what the range is. And because Newton-Raphson method converges pretty fast, so if you do maybe one more iteration after this and you see still the value is not changing much, so it remains 0.5354 something of that sort, you can straight away say that option A is the answer, because Newton-Raphson, if converges very fast, converges to the root very fast, and if in subsequent iterations you are getting more or less the similar value, that means, and you can see the range which is 0.5, the other options don't really match here with 0.5 something, so that is the answer you can straight away say without doing too many iterations here. So I can maybe do one more iteration for you. So if I calculate say x3, so x3 I'll calculate as x2 minus f of x2 by f dash x2. So x2 is actually 0.543. So 0.543, let me write this down, 0.543 minus f of x2. So I'll put 0.543 in f of x. So 5 into 0.543 minus 2 into cos 0.543 minus 1. So it's a very low value, which is 2.675 into 10 to the power minus 3 divided by f dash x, with x being 0.543. So 5 plus 2 into cos 0.543, which is 6.0334. So if you calculate this, you get 0.543 minus 2.675 into 10 to the power minus 3 divided by 6.0334. So the value again you find it to be 0.5425. So you can see it has already converged, because if you calculate say x3 minus x2 absolute value, you get 0.0005, right, which is already less than 1, is it not? So it's already less than 0.001, which already fulfills our condition. So if you have to write both of this up to 2 decimal places, you would write this as 0.54, this as 0.54. So that means you are getting the same root with multiple consecutive iterations. You have already converged at the root. So 0.54 is the root, and it is within the range of 0.53 to 0.56. So that is going to be our answer. So that being said, let's look at the next question. However, I'll not solve this question because I have already solved one question on bisection. I'll just help you figure out the initial condition for this. So this is a bisection method, and for bisection method we need two initial points to start from, right? So our function is f of x, which is x cube minus 4x plus 9, right? And so we need two such values such that at which f of x for one of the value will be positive and one of the value will be negative. So let us try a few values. So what is the value at f of 0? So at f of 0 the value is 9, which is positive, and this is asking for the negative root, so we need to make sure that we have so the root, that is the x value where we get f of x as 0, that is actually negative. So we try out with say minus 5 or something, or even minus 2, I guess. Should 2, let me check. 2 to the power 3 minus 4 into 2, minus 2 to the power 3 moment, 3 minus 4 into minus 2 plus 9, so you get still 9. Okay, so if I take f of minus 5, let us calculate f of minus 5. So cube, minus 5 cube, minus 4 into minus 5 plus 9, which is minus 96. Okay, so I'll take, say, these two initial conditions, which is 0 and minus 5, because I came to know I have to calculate the root of this function, which is in, this is f of x, this is x, so I have to calculate in this area. This is because I have been asked to calculate the negative root, that means I have to calculate at x less than 0. So I take 0 as one of the limits. At 0 the value is positive, so this function is somewhere here, 9, and then I take a value, I just randomly try and calculate where this function becomes negative. So I take, say, minus 5, I tried minus 2, it was still positive. I tried minus 5, I found out that the functional value is negative, so I take minus 5, so the function is somewhere here. So the root occurs between minus 5 and 0, that's what I definitely know. Now I have to start iterating. I have to calculate the value at minus 0.25, which is somewhere in bit, which is the midpoint of 5 and minus 5 and 0. I calculate here and check whether it's positive, negative, and repeat the bisection. So so here I can tell you that the answer would come out to be this, minus 0.2706. If you keep calculating it for multiple iterations, you would reach closer to the solution. So yeah, that is basically how you do this. You can solve it on your own. I just wanted to show you how to take the initial conditions. So sometimes the initial conditions you have to just try around a few values, you have to do some trial and error and check where the function becomes positive. I mean, you might get positive or negative values for different initial conditions, and yeah, so you need to try out some values in order to check that. So here I tried out a few values and I got that minus 5, the functional value is negative. For 0 it's positive, so I just take that as my initial condition and I start bisection method from there. So yeah, you can try to solve this, and when you do, you will get the solution as minus 0.27 roughly, sorry, minus 2.7 roughly. Okay, alright, so we have another question on the trapezoidal rule, which is, again, that means we are doing integration. So okay, this is again integration, and we have been asked to do it in 5 subintervals. That means we need to divide this 2.5 and 4 into 5 different parts. So we have, this is 2.5 and this is 4. We need to divide it into 5 different sections, so with 5 subintervals, right? So 1, 2, 3, 4. We need 4 points in between this, so that we have total of 5 intervals. So first interval, second interval, third, fourth, fifth. So we need to take 5 different intervals. So we have to first divide 2.5 and 4 into 5 different parts, and yes, and we can do that. So let us see. So basically what that means is, between you need to find a value which is 1/5 of the distance between 2.5 and 4. So this point would be 2.5 plus 1/5 into 4 minus 2.5, right? So I want to divide this section between 2.5 and 4 into 5 divisions, 5 equal divisions. So the first point that I would get would be, so the total distance is 4 minus 2.5, which is 1.5. I divide that in 5 divisions, that means I get 0.3. So my first point would be 2.8, right? So this would be my first subinterval. Then what would be my second subinterval? It would be 2.5 plus 2 by 5 into 4 minus 2.5, which would be basically adding 0.3 to this, which would be 3.1, right? So 3.1. Similarly, again 0.3. If I add 0.3, 3.4. Then again I add 0.3, which is 3.7, and then we get 4. So these are the 5 subintervals that we have, and we have to use the trapezoidal rule in calculating this. So next what we do is we calculate the values at all these subintervals. So let us do that. We have our f of x is ln, this ln of x. Okay, now we calculate the values at each of this. So let me calculate ln 2.5, which is 0.9163. I calculate ln 2.8, right? I get 1.029. ln 3.1, it's 1.1314. ln 3.4, 1.2238. ln 3.7, 1.3083. ln 4, which is 1.3863, right? So these are the, this was I think 96. Yeah, so we have all these values. Now we have to calculate using the trapezoidal rule, using 5 different subintervals. So let us write the equation. At least you can solve it on your own and get the answer. So the equation for the definite integral would be half into the first trapezoid, which is 2.8 minus 2.5, into the sum of these values, which is 0.9163 plus 0.9163 plus 1.0296. This is the first. Then for the second, you have 3.1 minus 2.8 into 1.0296 plus 1.1314. Then for the third, similarly, you have 3.4 and 3.1, and the values respectively are 3.4 and 3.1, which is 1.1314 plus 1.2238. Then the fourth one is half into 3.7 minus 3.4, so 3.7 minus 3.4 into the values at 3.7 and 3.4, so 1.2238 plus 1.3083. Then the final one would be plus half into 4 minus 3.7, and the sum would be the values at 3.7 and 4, which is 1.3083 and 1.3863. So if you calculate all of this together, you will get the value would be somewhere roughly 1.75 or something of this sort. So basically you will get this as the answer, 1.74. It will be in between 1.74 and 1.76 if you calculate this entire thing. So what we did overall, we had this function which is ln of x. We had to calculate the integral, the definite integral of ln of x dx from 2.5 to 4, and now using trapezoidal rule with 5 subintervals. So what we did is, first we divided this range, which is 2.5 to 4, into 5 equal parts. So the first was 2.8, 3.1, 3.4, 3.7. How did we calculate that? So this difference was between 2.5 and 4 was 1.5. Now if you want to divide that by 5, so we get 0.3. So it should be, for equal spacing, it should be placed 0.3 distance apart. So the first point would be 0.3 plus 2.5, which is 2.8. Then again add with 0.3, which is 3.1. Add with 0.3, 3.4. add with 0.3, 3.7, and you get 4 as the ending point. So we have now 5 intervals or 5 sub intervals, and we calculate, so we consider each of these intervals as one trapezoid, as one trapezoid, and we calculate for all these 5 different trapezoids, we calculate the area of the trapezoid. So how we do that is half into the height of the trapezoid, which is given by b minus a, that is 2.8 minus 2.5 for the first trapezoid, into the sum of the sides, which is basically we have calculated. So we calculated ln x, which is the function f of x, which is ln x. We calculated the value of ln x at all these values that we need, 2.5, 2.8, 3.1, and so on. So we calculated all those values. So the area under the first trapezoid is half into the height into the sum of the sides, which is given by this. Area of the second trapezoid is half into the height, which is 3.1 minus 2.8, into the sum of the sides, which is f of 2.8, f at 2.8 and f at 3.1, and so on. So we calculate each of the 5 sub intervals, all the 5 different trapezoids, we calculate the area, and we sum them up, and we get, if you do that, you will get a value which is within the range of 1.74 to 1.76. So here the solution would be option B. So that I hope that is clear. There is some question in the chat. Okay, I'll share with you a link using which you can just see the live sessions, and they are being recorded and uploaded, so you can find this. I'll share a link with you. Just hold on a moment. Yeah, so I have shared a link with you which you can refer to for the PDF of the sessions, as well as for the links. You'll get the YouTube links for the recorded sessions that we are having. Okay, now that I hope this is clear, so we'll move on to the next question. So it's about RK4 method. Now we are going towards solving differential equations, ordinary differential equations. So you have this ordinary differential equation, which is of the first order, which is 10 into dy by dx plus x square e to the power x equals y into cos x plus x into sin y, with the initial condition as x equal to 0 and y at x equal to 0 is 5. So if you want to solve this, how do you rewrite the equation first? So can anybody answer this? So how do you need to rewrite the equation, and then you can start doing the RK4. So if I just do some manipulation here, so you will get 10 into dy by dx equal to, I bring all the terms to one side, so sin y minus x square e to the power x, right? And now this constant also has to go, so it has to be like this: 1 by 10 y cos x plus x sin y minus x square e to the power x. So we have to first rewrite the equation in terms of dy by dx is equal to f of xy, right? We have to rewrite the equation in this format, and then we can start doing RK4. So first we have to rewrite and then use RK4, right? So it needs to be in this form. So this will be our f of xy. This entire thing will be our f of xy. So we need this part in order to start the RK4. Okay, so here you will have option C. The initial condition will remain the same no matter what you are making the change to the equation. So now that we have done this, let us try to actually solve a question for the RK4 method. So let me do the rewriting first. So if we write dy by dx, how do we write it? So y cube minus x square into 1 by 4, right? So this is our dy by dx. So this is our f of x comma y. So I'll just rewrite this. F of x comma y is 1 by 4 into y. So let me write 4 as like this, otherwise it will cause confusion. Yeah, so 1 by 4 y cube minus x square. Now this is our f of xy, and now the initial condition has also been given. So x equal to 0.5 and y, so just a minute. So this is our initial condition, which is at x equal to 0.5 the value of y is 2, and now we have to, with the step size of 0.2, we have to calculate y at 0.7. okay, so let me write down the equations for RK4 method first. So let's say k1 is equal to f of x comma y. Now k2 is equal to f of x plus h by 2 comma y plus h k1 by 2. So h here is the step size, which is 0.2. So as you can see, if you are at 0.5, if you just go by a step size of 0.2, you will reach 0.7, which is what we have to calculate here. And k3 is f of x plus h by 2 comma y plus h k2 by 2, and k4 is f of x plus h and y plus h k3. okay, now how do you calculate the y at x plus h? This, it will be y at x plus h by 6 into k1 plus 2k2 plus 2k3 plus k4. This is how you do it. Okay, now let us calculate k1. So I'll write it down here. So k1 is equal to f at x equal to 0.5, y equal to 2, right? Because that's what has been told to us already, that at x equal to 0.5, y is equal to 2. So that is our initial condition. So what is k1? Let us calculate that. So f of xy, so y cube, so 2 cube minus x square, which is 0.5 square, whole divided by 4. So this is 1.9375, right? Then we calculate k2. So what is k2? So f of x plus h by 2. So x is 0.5, h by 2 is 0.1. So we calculate 0.6, and y plus hk1 by 2. So that is, let me take a bit more space to write this. Okay, I'll just write it here. k2 is equal to f of 0.5 plus h by 2 is 0.2 by 2. Now, and y plus, so y was 2 earlier, plus h, which is 0.2 by 2 again, into k1. k1 is 1.9375, right? So we calculate that. How much is that? So it's basically f of 0.6 comma 0.1 into 1.9375 plus 2, 2.19375. and how much is this? So if you calculate this, it is cube, the y cube minus x square, which is 0.6 square, whole divided by 4, which is 2.5549. We have four digits there, so we write till 4 digits, 2.5494. okay, that is k2. Now we do similarly, we calculate k3, which is what? Which is again 0.5 plus 0.1, which is 0.2 by 2, comma 2 plus again 0.1 into, that is h by 2 into k2. So k2 is 2.1 2.5494. And how much is this? So you have 0.6 comma 2.5494 into 0.1 plus 2, which is 2.25494, right? Now if I calculate this, how much will I get? So this cube minus x square, which is 0.6 square, whole divided by 4, we get 2.7764. okay. Now next we have to calculate k4. So for k4 you say it's x plus h, so you have 0.5 plus 0.2 comma y plus hk3. So y is 2 plus h is 0.2 into k3. K3 is 2.7764. Now this is f of 0.7 comma, so 0.2 into 2.7764 plus 2, which is 2.55528. Now how much is this value? Let us calculate that. So this y cube minus 0.7 square divided by 4, you get 4.0486. Now you put it into this equation. So y at 0.7 is equal to y at 0.5. So y at 0.5 is 2 plus h by 6, which is 0.2 by 6 into k1, which is 1.9375 plus twice of k2, which is 2.5494 plus twice of k3, which is 2.7764 plus k4, which is 4.0486. okay. Now if you calculate this entire thing, you will get a value which is close to 2.5546. I can calculate that for you. So 1.9375 plus 2 into 2.5494 plus 2 into 2.7764 plus 4.0486 whole into 0.2 divided by 6 plus 2. So you get this would be close to 2.5546. So that is what the answer is. So this is how you do RK4 method, how you solve a differential equation using RK4, that is Runge-Kutta fourth order method. Is it clear? Is the process clear to you? Okay, I hope this is clear. Now let us move on to the next question then. So we also covered structures in this particular in week 11. So let us try and solve it. Write a C program to add two complex numbers using a function and structure, of course. So first, apart from the include, say we write the include thing, which is fine. First I have to define the structure, right? So let us first define the structure. So we write struct, which is the keyword for defining structure. So struct, say I am saying its structure is called complex, and I open a bracket there. Sorry, I have say float A and float B, right? And I close the braces and I write complex again, so that I can use only the word complex. I define the structure itself as complex, that is a new data type. I am defining a new data type here, that is having two different members. So this is the tag, this is called the tag, and these are the members of the structure. So basically, if I am talking about complex numbers, so I am talking about a plus ib. So that is why I have taken two different floating point values which represents a and b as members of the structure. Okay, and this I use so that now I can, this is a new data type. So this is a user defined data type now, and I can define define structures using just complex. I'll show you how. Now next I have to define a function, right, which takes two different complex numbers and adds them up. So let me write that function. So it returns what? It returns a complex meaning a structure with two floating point members. Okay, so it returns complex. So let me say add complex. This is my function name, and I take two different complex numbers as input. Say complex num1 and complex num2. Okay, now let us write the function. So I define complex sum. Okay, now after I define a complex sum, what I do, sum dot a, which is now this sum, which is a structure having two different floating point members, which is a and b. So I to access a, which is a member of the structure sum, I write sum dot a is actually the summation of num1 dot a plus num2 dot a, right? And similarly sum dot b is equal to num1 dot b plus num2 dot b. So I have added up these two structures which I took as input, that is num1 and num2. So two different complex numbers I had taken as input, and now what do? I have to return this sum, which is a structure. So I have used only the word complex. So because I have defined it as a new data type now, so I just need to write complex here instead of writing struct complex. If I had not written as so let me maybe write this as a little bit different, so I'll just write comp. So this is a new user defined data type. So here I just need to write comp. Okay, here as well. So I write comp, and the rest is done. Otherwise I would have to write struct complex for all of this. I have to write struct complex. So just to save me that pain, I have used this, I have defined this as a data type, and I am using that. Now what would happen in the main function? So let me write down the main function, int main. Now you just define two different numbers. So I say num1 and num2, and num1 dot a is equal to say 5.5, num2 dot a is equal to minus 2.5, whatever, just define some values. Num1 dot b is equal to minus 3.1, num2 dot b is equal to minus or plus whatever 10.2. Now after this what I write is I call this function, which is add complex, and I need to store it somewhere, right? So I write complex, sum is equal to add complex. I call this function and I pass these two numbers or these two structures, num1 and num2. Okay, so I get this sum here in the main would have the summation of these two complex numbers. So this is basically how you can define a structure, and you can write a function which takes structures as input and gives out the structure as output. So you can pass structures to functions as well. So that is what I wanted to show you. So I hope this is clear. If there is any doubt, you should feel free to ask me. If not, then let's move on to the next part. So I'll briefly talk about the static variables. So static variables, first of all, what does static mean? So it is a type of storage specifier. So storage specifier meaning that it has something to do with where the variable is stored and uh, how long is it stored. So basically we can define till how long the variable should exist in a code. So that is what this storage specifier does. So this is used to specify how long or specify till what point, till what time should a variable exist. So that is what the storage specifier helps us to specify. Okay. Now there are 4 different types of storage specifiers: automatic, also known as local; external, also known as global; static; and register. So local basically means local and global are more related to the scope. So if we are defining a variable which is local to the function, so it will stay until that function call is over. Once the function call is over, the variable is destroyed. And a global variable is available to all the functions, so it stays. So it okay, let me write these things down. So local basically means variable is destroyed once function call is over. Global means a variable is destroyed at end of the code. Variable stays until the entire code stops exits. I mean the entire code finishes running. Okay, so variable is destroyed at end of code execution. Right. Now we are going to talk about the static one here, and there is a special category of storage specifier which is or variables called register variables, which are supposed to be faster than normal variables, faster than local variables, but with the current compilers we don't really need to use register variables because the current compilers already have inbuilt optimization techniques. So you don't really need to use register variables anymore. So they are more or less outdated until you are doing very embedded systems approach and so on. So currently what is important to us is local variable, global variable, and static variables. So static variables, what exactly that is that it's a variable whose so across multiple function calls, the value of a static variable, the static variable will not be destroyed. So it is very close to the definition of a global variable, but it is not exactly a global variable. So the variable, a static variable will stay until the end of the code execution. But what is the difference from global and static? Global is available to all functions. This is available to, or I shouldn't say available, I should say accessible to all functions. To all functions. While if you say static, then static is also the variable is destroyed at the end of the code execution, but it is local to the function where it is called, function where it is defined. Okay, so that is the difference, that the static variable is actually local to the function where it is defined, but it stays till the end of the code. It is not destroyed before the code stops executing. So this is an example that I have for this for the static variable. So first we will look at the right hand side thing. So here we are defining a function which is called fun, which returns an int, and what it does is uh, it does it defines a int count, initializes it to 0, and does a count plus plus, which means increases the value by 1 and returns the value. So okay, and in the main function what we do, we print the value of whatever fun returns. Okay, so here if we just print it out, you should get 0 and 1, sorry, you get 1 and 1, because the first time it is called, you define, first time the function is called, you have a count 0 defined, count 0 initialized. So this is a local variable, right, and local to the function called fun. Okay, now it increments the value by 1 and returns that value. So after the function call fun, the first function call is over, the variable count is destroyed. Now the next time you again call fun, again a new local variable is created, which is the name count, and it is initialized to 0, increase the value by 1 and return that value to the calling function. So again you get a value of 1. But what happens in the case of static variable? If you define this count as a static variable, what happens? So now this is now a static variable. It's not a local variable, but it's a static variable. So now if you try to print this, you will have a value of 1 and 2. So how that happens is, the first time you call the function fun, it initializes this count to 0 as a static variable. It increments the count to 1, so the first time I call fun, okay, so it defines count is equal to 0 and count plus 1, so count plus plus, so now count is equal to, so it becomes 1 now, that is what is returned, right. Now the second time you call fun, the count still exists as 1 because it is a static variable. So because it's static, it retains its value, it is the variable is not destroyed, and it retains its value, so the value is still 1. Okay, now again you do a count plus plus, so the value becomes 2, and this is what is returned. So you have, the second time you call it, the value becomes 2. So why static variables are important is because you can use them in recursion. So in recursion, static variables play a very major role because of this particular tendency that you can across function calls, the value of static variables will keep adding up, it will not be destroyed. So you can calculate how many recursion loops the particular recursion algorithm is going through. So you can do a lot of stuff like that. So that is what the static variable is here. So it is kind of like a global variable, but if you see, the static variable count is actually local to the function called fun. So it is not a global variable, it is not accessible from int main, it is accessible only within the fun, but it stays, it is not destroyed until the entire code execution gets over. So that is the advantage of static variable. Okay, so I hope that is clear, and if that is clear, then we will go and visit a example of recursion. Okay, so let's look at the example for recursion. So here this question is to write a C program to print the Fibonacci sequence using recursion up to 10 terms. So Fibonacci is, if you don't remember, it's 0, 1, 1, 2, 3, 5. So every subsequent 2 digits. So 0 and 1 add up to 1, 1 and 1 add up to be 2, 2 and 3 add up to be 5, then 8, then 13, 21, and so on. So this is the Fibonacci sequence. So what we do is, alright, we calculate Okay, so we have to calculate it up to 10 terms. Now we use recursion, and we have to use recursion. So I define a global variable which is 10, so that both int main function as well as the recursion function can access this. So I define term as this is a global variable, right? And in the main function I define 2. So for Fibonacci sequence you need 2 starting places, which is you need to recursively keep adding them and you get the new term. So I take 0 and 1, so those are the first 2 terms. I just print them out. So you have 0, 1 printed out. Now what we do next, we reduce the value of term by 2, because we now need only 8 more terms. The first 2 terms we have already printed, so we need 8 more terms. So we just reduce, so term becomes 8 now, okay, from 10, and we just pass this Fibonacci to, so this is because term is a global variable and we have not defined any more variable with the name term, with the identifier term inside the main loop. This is the same global variable that has been modified. Okay, so here the global variable is modified. Okay, the global variable is modified. Now we pass okay, the call, this should be Fibonacci sequence. Okay, so Fibonacci sequence into priv and new, so we pass 0 and 1 in the Fibonacci sequence. Now what happens, we define a static int variable. So this is a static variable as has been written here. So this is a static variable and it has been initialized to 0 the first time the function Fibonacci sec has been called. The variable I has been initialized to 0. Okay, and we define some temporary variable. We check if I equals term, that is now term is 8. So if I equals 8, then we will return 0 simply. Okay, alright. Now if I is not 8, then we go for term. We calculate the next Fibonacci sequence, because if I is term, that means that we don't need to calculate anymore, because we have already calculated 10 numbers of the Fibonacci sequence. So now if I is not 8, then we calculate the previous plus new, which is 0 plus 1, we get 1, and we just swap the numbers. Now previous will have 1 and new will have 1. Okay, and we print the new value, which is 1. So we have printed 1, and now I plus plus, so I becomes 1. Again we call, so this is again Fibonacci sec. So we call Fibonacci sec with the values 1 and 1, and it goes and it checks I equals term. No, it is not equal to term, because I is 1 and term is 8, so it is not equal. So it goes to the else part, calculates it, gets 2 printed, and I becomes 2 as well. So and next again it calls Fibonacci sec, which is with the values of 1 and 2. Then again you check I is 2, it's not 8, so you have again the next value is calculated 3, and the swapping takes place. I becomes 3, and you again call Fibonacci sec with the values 2 and 3. Okay, now you go and check I value is 3, it's not 8, so we'll go to the else part. Again we will calculate, we will have 5 printed and the swapping taking place. Then I becomes 4, because this is the 4th time the recursion has happened, so I becomes 4. Okay, now again we call the Fibonacci sequence, Fibonacci sec with the value 3 and 5. It goes, checks, I value is 4, term is 8, so goes to the else part, gets 8 printed, because 3 plus 5 8, and the swapping takes place. I becomes 5, so I'll also track the value of I. So I was defined as 0, I was defined as 0 the first time it was called. It became 1 here, 2 here, 3 here, 4 here, 5 here. Okay, I became 5 here. Now again this will continue, this will become 13, so I becomes 6. Then again we call this, it still it is not equal to 8, so the else part will be satisfied, so the else part will be executed. It's 21, so I value becomes 7. Now in the still it is 7, it is not 8, so I can calculate it, so it's 34. So now I value becomes 8. Okay, now I value becomes 8 when you go back here, so it will get equated. You have I equals term 8 equals 8, which is true, so it will simply return 0. It will come back to the previous recursion loop and it will exit the else condition, and again it will return 0, and it will keep returning, and it will finally return to the main function and it will exit. So you will have your entire Fibonacci sequence for 10 terms. So because 8 terms have been printed, right? So it was 0 here, 1 2 3 4 5 6 7 8, so 8 more terms has been printed and 2 were printed earlier, so total of 10 terms. These are the 10 terms of the Fibonacci sequence. So you can see how this static the static int variable I here helped us in knowing the number of terms that we were that the number of terms of the Fibonacci that we were calculating, because its value did not the variable did not get destroyed from function call to function call, because it was a static variable. Now if it is not, if the variable is not destroyed, the value gets carried forward and incremented each of the times a new term is printed out. So that helped us in knowing how many terms were printed out, and it also defined the recursion. So this is where, this is the condition where the recursion stops, right? So this is the recursion elimination condition. So that is very necessary, very important when we do recursion. There should be a condition to eliminate the recursion at some point. So that is here it helped the static variable I helped us out a lot in defining the recursion, proper recursion condition or proper recursion elimination condition, so that the entire recursion ends, right? So you have 10 different numbers being printed, 10 terms of the Fibonacci sequence being printed. Is it clear? Okay, so if this is clear, then that's all I have for you today. So we'll meet at the same time next week on Tuesday, 7 to 9 p.m. Okay, thank you for joining.